Hello guys, welcome back to my channel. Today I'm going to show you how you can do failover between two ISPs. So you have here ISP1 and ISP2. So the goal is if ISP1 is not available, that ISP2 is able to pick over. So actually the ISP routers have already been configured. You have the 8.8.8, the loopback 0, which is going to be used to indicate that there's internet available, and then there's second loopback 1.1.1.1. It's going to be used on ISP1 to track if the interface is up or not, and so the ISP1 is and ISP2 is already configured. The home office sole router is not yet configured, and so we're using this subnet says 64.64.64.0/30 is going to be to ISP1, and 65.65.65.0/30 is for ISP2. So yeah, let's get into the configuration. Before I continue, so this is what we have here. The interface is on the ISP1 is going to be .1 of 64.64.64.1. So that's going to be on ISP1, and then the 65.65.65.1 on ISP2. Okay, so the .2 is going to be on the home office router, and then for the LAN subnet 192.168.20.1 for the PC1 and .2 for PC2, and then .100 for the gateway. I'm just going to push this one aside, and let's get into the configuration. Alright, so right now I'm in the home office router. We don't have anything configured on the home office router, so I'm going directly into the configuration. First, I'll configure the serial 10 interface. Now short IP address 64.64.64.2. Okay, do the same thing for serial 11. Okay, serial 11 is done. Now for fast DNS 0, the LAN section. No shot, very important, because otherwise interface is not going to be up. Let's see if the interfaces are all up. Show IP interface brief. So this up. Okay, we forgot to do no shot here. That's why it's always important to check the interfaces. Okay, fast internet 0. So we're going to go into fast internet 11 and do no shot. Serial 11, sorry. So let's to show IP interface brief again. Okay, now it's up. Now let's configure the PCs and make sure the PCs can reach their gateways. So for PC1, the IP is .1, 192.168.20.1. We'll configure the gateway. Okay, that's been added. Let's make sure the gateway is reachable. Ping 192.168.20.100. Responding. Do the same thing for the second PC. Okay, PC is reachable. Let's try to ping it. Let's try to ping the gateway. Okay, so the PCs are configured now. So the goal is to allow this LAN devices, the PCs, to be able to reach the internet. Okay, and the internet here is represented by 8.8.8.8. Okay, for ISP1 and for ISP2. So if ISP1 is not available, then ISP2 should pick over. But then how do we do that? Is we have to make sure that there is the NAT statement is applied on the Soho router. That way, sorry, not we're going to configure NAT statement on the Soho router, but we have to allow the route map configuration on the Soho router. That way, it basically decides if ISP1 is down, so ISP2 picks over. Okay, so let's go on configuring the Soho router with the Soho route map. The first thing we want to do on the Soho router is to create the access list. So we're going to create the access list for the LAN subnet IP access list standard. Should give a name, standard NAT. Okay, yeah, let's give it, call it NAT. Permit 192.168.20.0. Then we'll give us wildcard mask. The wildcard bits, so it's going to be 0.0.0.255. Okay, so access is created. Now we have to create a route map. Exit over there. Route map for ISP1. Say permit 10. Permit sequence 10. And then we're going to match IP address that we created on the for the access list, IP address NAT. We're also going to match the interface, the exit interface here, which is going to be the 1/0 serial 01/0. So we're going to match interface serial 1/0. Okay, so that's done for ISP1. Now we're going to do the same thing for ISP2. Going to exit out of there. We're going to create a route map for ISP2. So it's going to be route map ISP2 permit 10 sequence 10, the same sequence. I'm going to match IP address NAT. We're also going to match the interface serial. This time it's going to be 1.1. Okay, so that's done. We'll exit out of here. Now, one thing I forgot, before we even apply this access list, we have to define which interfaces on the Soho router are inside and outside. Okay, this interface first 00 is going to be the inside. That's where you have our LAN. Okay, and then the interface, the serial interface is going to be outside. So serial 10 outside, serial 11 is outside. So let's start. Let's do that first. Interface serial 10 IP not outside. And then do the same thing for serial 11 IP not outside. And then interface F0/0 IP not inside. Okay, now we can now apply the route map, because we have the inside interface defined, we have the outside interface defined. So we can now say IP not inside source route map ISP1. So we're going to apply first for the ISP1. Let's see what's the option here. Interface S1/0 overload. Okay, so basically we're saying we're applying that access list, we're applying that route map on interface S0. Okay, so that we're done for interface S10, and now we're going to do the same thing for interface 11. Okay, for ISP2. So we're going to do the same thing for interface 11. And for ISP2 as well. So okay, now that's done. What we have to do right now is, because we have defined how these LAN interfaces, how these LAN subnets can go to internet, but we don't know yet if this ISP fails, how is this one going to know that that one failed? So we have to apply, we have to configure IP SLAs. Okay, we have to configure IP SLAs for tracking the interface. If this interface fails, then this one picks up. Okay, so for IP SLAs, I have a cheat sheet here. Let me check what's it. So now we're going to configure IP SLAs. IP SLAs number 1. We're going to track ICMP ping. ICMP ICMP echo 1.1.1.1. Source interface 0.1.0. So we're going to constantly ping this 1.1.1.1. Okay, and that interface, to ping it, it goes out interface 10. Okay, so we're going to constantly ping that IP address, which is on ISP1, to track it down. And this timeout is going to be 5,000 seconds, and the frequency is I think it's in seconds. Let's say frequency of 5 seconds. We exit out of there, and then we we make create a schedule. Schedule for so we're going to have to track it forever, and we want to define it when we want to start it. We can start it right now. Start it now. We can start after some time. We can start, so you can basically define at what time you want to start it, but we want to start it right now. Okay, now IP SLA is created, but we don't know how to get to this 1.1.1.1. Okay, we have to create a static route that tells the Soho router how to get to 1.1.1. So this static route here is going to do just that. Okay, so IP route Okay, so the statement says if you want to get to 1.1.1.1, okay, you have to go out this exit through serial 10, and your gateway is going to be 64.64.64.1. Okay, so that's done. But then how about the NAT, the subnet that are in the LAN section? Okay, the subnet in the LAN section still don't know how to get to the internet. Okay, so we have to create a default route on this Soho router for these LAN devices, and that default route is, we say IP route 0.0.0.0.0.0. Okay, goes out. The gateway is going to be 64.64.64.1. Okay, so IP route sorry. So this statement says if anybody wants to go out to the internet, okay, to anywhere on the internet, on any IP, any subnet mask, your gateway is going to be 64.64.64.1, and that interface is being tracked by the SLA we just created, SLA tracking number 1. Okay, that's what this statement says. Now there's one more statement we have to add to track the reachability of that 1.1.1. So it's going to be track 1 IP SLA reachability. All right, so at this point we can even save. Now, if we want to do a test, let's say we come to PC1 and we're doing a test, okay? Let's say we're trying to ping 8.8.8. Ping 8.8.8.8. Responding, okay? So we can go out internet, okay? We can go out internet, and we can actually go to the Soho router and do show IP translations, and see all the translations we have in here. So what's going on right now is that on the Soho router we've said if these LAN devices want to go to internet, they can go out through this through serial S10. Okay, but then what happens when this guy actually fails? We haven't actually define how to get to this other one, so we have to create another static route from the Soha router that tells the LAN interfaces if you want to go out internet and this ISP1 is down, this is how you go. Okay, you have to go through S011. So let's do a trace route. If we do a trace route to 8.8.8.8. Okay, so the trace route says it goes through 010. Okay, 10. This is 010. It doesn't tell us what if this device fails. We can actually do a test, but before we do any tests, I just prefer we just configure the second static route. Okay, this one that tells the router to the LAN subnets to be able to go out through ISP2 if ISP1 fails. Okay, so let's go in there, configure terminal, and now we're going to give a metric. Okay, we're going to give a metric because this ISP2 is going to wait for some time before actually taking over. So we're going to give a metric of this one metric of, let's say, 10. Okay, so let's go out there, save, and now we can do a normal test. So what we're going to do is we're going to try to shut down the ISP2. Okay, we're going to shut down this serial 10 and see if serial 11 picks up. So before doing that, let me just double check something here. Go to PC1, do ping is still responding, and trace 8.8.8.8. Okay, still going through ISP1. Now let's shut down ISP1. We're going to go configure terminal, interface 0.1.0. Let's do shut. No, before doing shut, we're going to do a continuous ping here. Let's do a continuous ping. Oh no, what am I doing? Okay, continuous ping. All right, so continuous ping. All right, now we have a continuous ping on from PC1. Now we're going to go to ISP2 to shut it down, shut down that interface and see how that works. Okay, shut, and then go to, okay, so so there's some period of time when it's not reachable, and then automatically it switches over. Now it's reachable. Internet still is reachable, even though ISP1 has been shut down. As you can see here, ISP1 is shut down. So now it should be going through ISP2, but how do we know that? Let's go back to PC1. Let's do a trace route. If we do a trace, okay. So now we can see it's going through 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 ISP2. Okay, because you can see the gateway 65.65.65.1. So it's PC2, ISP2. Sorry. So let's bring back the interface on ISP1. Okay, let's bring back the interface on ISP1 and see if it falls back to ISP1. Okay. So here we do, instead of shut, we do no shut. Before doing no shut, let's do a continuous ping again. Let's do a continuous ping. Okay, continuous ping. All right, so continuous ping there, and now let's go here and do a no shut. Go back to PC1. Okay, if you can notice, there's some change here, a little change here, and that is when it flat back to ISP1. Let's just double check if we are now reaching internet through ISP1. Okay, we're going to do a trace route. You see, So now we're getting internet back on, through ISP1. So failover is working perfectly. ISP1 fails. If ISP1 fails, ISP2 picks over. So ISP2 and ISP1 comes back up, then internet goes back through ISP1. So ISP1 is like the preferred route. Okay. So basically, this is all about this video for today. Thanks a lot for watching, and see you in the next one.